In Chapter 8, we're going to continue talking about confidence intervals today, and we're going to start talking about confidence intervals that are not our normal confidence intervals of 90, 95, and 99%. We're going to talk about stuff that's in between, like 98%, 96%, maybe 68%. We're going to look at those numbers and how we can find out what we're going to do for those. So if we're looking for a confidence interval of 97%, we know we're looking for a confidence interval. We need to have the z sub alpha over 2. To find out what alpha is equal to, we say that alpha is equal to 1 subtract the decimal of our percent here. So we say 0.97. In this case, alpha is going to be equal to 0.03. So remembering that alpha stands for the end of our normal distribution. Oops, wrong button. The end of our normal distribution, when we have our tail, like this, and ignore that it's going off, and we have our tail portions here. This is the area of alpha. So we know that 0.03 is like 3%. So we have 3% split up between these two tails. We need to know how much in each tail, so we take the alpha and we divide by 2. So alpha over 2 is going to be equal to 0.03 divided by 2, which gives us 0.015. Now, we have 0.015 for each tail. So I have 0.015 here, and I have 0.015 here. So I need to know what is the z value here when I have my tail having this much, 1.5%, 1.5% for the area under here. So we need to know what number makes up from the mean to that z value. So I need to subtract from 0.5 this number here. When I do that, I get 0.485 is this area here. So this is going to be the area number we're looking up on our z tables. The table has here, the area is inside, and our z values are on the outside. So I need to look up the closest one to 0.4850. When I look up 0.4850, I have 2.1 and then 7. It actually comes out to exactly 0.4850. We got lucky on this one. So now I know the z value. So I know my z value is now equal to 2.17, and I can substitute this into the equation we got yesterday. So let's do a problem from start to finish when we're looking for a specific confidence interval. So if we have a sample mean of 11.091, and I have a standard deviation S of 14.405, and we're looking for a 90% confidence interval for this data. Notice that I used S here because the numbers I took, or that are taken from the book, is actually a sample of credit unions, and instead of making you calculate the mean and the standard deviation for it, I just took what they had. So we have the mean being here, the standard deviation S, because it's a sample, being here. So we're looking at the formula, x bar, subtract z sub alpha over 2 times your standard deviation divided by the square root n of your sample size. And remember that is less than the population mean. And then we have the same thing written on the other side here because the population mean is less than x bar plus z underscore alpha over 2 times s over square root n. So in this case, we have our x bar, we have our standard deviation, our population size is given to us in the book. The population size is 30. But we need to find out what is our alpha over 2. What is this z sub alpha over 2 going to be? So we're looking at, we want a 90% confidence interval. This is one of the standard ones that we had, but we can also calculate it. So if we're looking at alpha over 2, we know alpha over 2 has to be equal to 1 subtract this in decimal form, so 1 subtract 0.90 over 2. 1 subtract 0.90 gives us 0.10 over 2, which gives us 0.05. So each tail is going to have 0.05. And if we look at the picture again, I'll draw it over here. We're looking here at 0.05, and over here, 0.05. So we need to find out what is the area we have here. So we subtract that from 0.5. So 0.5 subtract 0.05 is going to give us the area in here, which is 0.45. We look up 0.45 in the area percentage part of our Z table. Hold on one second while I look that up. So when you look it up, you get exactly between Z being 1.64 and 1.65. Both of those are the exact same distance apart. So we can go with the middle number, but your book has decided that it's going to go rounding up. So we're going to go with 1.65 as our Z. I'm going to erase all of this mess here that we calculated with. And we're going to find that our Z is 1.65. So we're going to say X bar, which is 11.09, minus 1.65 times our standard deviation, 14.405 over the square root of 30. And we get 6.752. But that is less than mu. We have to figure out what is the upper range. So we know the upper range, we're just going to change here to a plus sign, and we can calculate that number. We get 15.430. Notice that I rounded to 3 decimal places on both of these. Why did I round to 3 decimal places? Because I have here my standard deviation is rounded to 3 decimal places. If my standard deviation was rounded to only 2, my mean was rounded to only 2, I would keep 2, but because my standard deviation has 3 decimal places, you go with 3 decimal places. So the next formula we have here is going to be the formula to determine the sample size we would need to get an accurate information for an estimate. So our formula for the minimum sample size needed for the interval estimate of a population mean is going to be n, remember n is sample size, equals z sub alpha over 2 times sigma, which is your standard deviation, divided by e, capital E there, not the lowercase e, that equals 2.718. And we're going to square this. So in this case, n is our sample size. What we're looking for. This is going to be a z value. This here, remember, is sigma, which is our standard deviation. And E, this big E is a new term. This big E is going to be our error. So within how close do we want to come? Do I want to come within $5? Do I want to come within 10 people? How big of an error can I possibly have? So let's try using this formula with a problem. So here's the problem. The college president asked the statistics teacher to estimate the average age of the students at their college. How large of a sample size is necessary? The statistics teacher would like to be 99% confident that the estimate should be accurate within 1 year. From a previous study, the standard deviation of the ages is known to be 3 years. So what we're looking for to fill in this problem, we need to know our standard deviation, which here is 3. We need to know z sub alpha over 2, which we can't really find out of here easily. So what do we need to look at? Is we're looking at 99% confident. So we know we need to say 1 subtract 0.99. So we get 0.01 over 2, which gives us 0.005. So we know we subtract this from 0.5000, subtract our 0.005, and we get 0.4950. We look up this percentage, and the z-score for that percentage is going to be z equal to 2.58. So now we substitute into the formula. Oh, actually, we need to know that within 1 year. So we know that our E is equal to 1 year. So now substitute in the formula, we say N equals our Z sub alpha over 2, which came out to be 2.58, times our standard deviation, which is 3, over our error, which is within 1 year, and square it. When we do the math out here, we get 59.9. Because we can't have a 0.9 student, we round up to 60 students. So the size that we need for a sample would be 60 students. We don't have the 60 students, we're not going to have an accurate estimate.